Okay, folks, so today is our last data day. We have to cover things that we missed in Form 1. So today's learning intention is to compare data on objects in our solar system. And this is RAG statement number 3 from Earth and Space RAG that we did in first year. So we're going to play this game. It's called Play Your Cards Right. It was around in the 80s before you were even a thought. And the way it works is you have to decide, once you see a card, is the next card going to be higher or lower? Okay, so nice to see you, nice. So you have to guess higher or lower. So the sun, and it's giving you distance. Do you go higher or lower? So let's see how lucky you are. So it went lower. Lower again. So is this next card going to be higher or lower? Higher. What do we think? Lower. Okay, so we have a look at these guys. So we look at star. Is the next object going to be bigger than a star, smaller than a star? Okay, so if you went bigger, you did good. So now galaxy. Is it going to, the next card going to be bigger or lower? Okay, it was lower. Solar system. So we're going to go bigger or smaller. So we actually went ginormous. So we have loads and loads of galaxies. Oops, I went too fast. Universe, we went bigger again. Don't know if there's one more, but we'll check. So decide higher or lower. And that was it. Okay, would have been fun if we were in school after Easter break. So you just need to make a note of this for yourself. I need to be able to compare the objects, and the things you have to compare are on the basis of mass, gravity, size, which may be written as diameter, composition, which may be written as density. And I can put the data in order or group the data together is what you're going to be able to find out what to do. Okay, so pause that if you need to. Now, excuse me, I'm going to do the mass for you now. So in terms of mass, we are going to put them in from smallest to largest, or smallest number to largest number, and I'm doing this in real time with you, so you may have to shout at the screen to make sure I've done them right. So this is would be the smallest. The moon here would be the next smallest. Then we would go all the way to Mercury. We would go all the way to Mars. We would then go to Venus. We would go to the Earth. We would go to Neptune. Oh, wrong. We'll go to Uranus. We would go to Neptune. We would go to Saturn. And we would go to Jupiter. So you would make a list of these. So I'm just going to do the initials. So it would be P. I'm actually going to omit the moon data because it's really not necessary. But in terms of our planets and our planetoids, it would go Mercury, Mars, Venus, Earth, Uranus, Neptune, Saturn, Jupiter. So that's my list for starters. And now when I'm just looking at the masses, is there any kind of groupings that might be able to go together? Because you're going to have to try and graph data that the SEC are going to give you. So in terms of the data that I would put together, I would definitely put everything from Neptune down together. And I might put these guys together. You could even subdivide if you so wished. The idea that Mercury and Pluto are really, really small. And maybe Mars, so you could even subdivide that group again in here if you so wished. So I'm just going to now swap to a graph. And this data that we have, in terms of our data, we have words and we have numbers. So there's only one type of graph that's going to work for this. So you can have a little think. I need to find my page. So you can have a little think while I am swapping over. No, I don't know why that decided it didn't want to work. Here we go. So if you had to draw a graph, you would draw your x-axis like so. You would have to label it up. So this is mass, and it's got very specific units. So it is 10 to the 24 kilograms, so that's ginormous in terms of mass. And down here we're going to have our planets. Now I'm going to do my very easy method. I know you have a different one. Just sums up 9 planets. So in terms of my mass, we've said that we would have different groupings. So sometimes, because we have Jupiter being nearly 2000, you can actually make 2 y-axes for yourself, and you just use different numbers. Mass, and it is 10 to the 24 kg. So I might decide here 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to make this one 1000. I'm going to make up here, won't leave me right now, I don't think, 2000. So that's won't leave me right there. And then over here I might decide, because Saturn is my biggest at 600, that I would go 100, 200, 300, 400, 500, 600, 700. So in that way then you can take care of 2 pieces of data that are, or sets of numbers that are really, really big. So we know now that Mars is going to be very, very small. So we worked out, I'm hoping that I'd have to do a bar chart. So 4.87 for my bar, roughly here. We then go 5.97 for Earth. So just have to make it a fraction bigger. You'll be way more accurate than I'm going to be. We are ignoring the moon. We have 0.642 for Mars. So these are all probably very, very big, or too big, but I don't have a ruler, so I can't make them right, but you would be able to do it. We then go to Jupiter, 1898. So that is going to be 255, 750, 758, 75. We said it's 1898, so it's going to roughly be around here. So this is going to be the wrong thing. So we said the 1898 is for Jupiter. So I go all the way. Now you have your ruler and you're going to use your boxes, and you're going to be so much better than me. I'm going to color this guy in like this. We then go to Saturn, 568. So this is 5. This is 7650. So it's going to be somewhere around here. I'm just going to label my mass so we'll be able to tell which goes with which. We have then 86.8 for Uranus. So this is 100, this is 50, this is 75, so 86 is roughly here. And we also have to do Neptune, 102. So 102 will just be here. And the last one we have to do is Pluto, and that's going to be teeny tiny. Okay, so this now is our graph showing our planets versus mass of planets. Okay, so if you have to draw a graph, you make sure you have your axes in there. You make sure that you have your scales right. You can use 2 y-axes if you need to. And you're going to do something like that for me. So we go back to here. Okay, so in terms of this, you have to, for diameter, for density, and for gravity, list them in order from smallest to biggest. And is there anything that the densities can tell you about what state of matter the planet might be made up of? And for gravity, I want you to look to see, is there a relationship between gravity and size? So does it necessarily mean big planet has a big diameter? Okay, so you're going to have sequenced them all and see, can you see a relationship? So it's going to be, I think that if the density is really low, the state of matter must be a gas. I think if the density is really high, the state of matter must be a solid, and see what you come up with. Similarly for gravity, I think that if the gravity is low, then the trend looks like the diameter is small or it's large, but you decide, can you figure that out? So in this next worksheet, we're just going to read through the questions. You can use the table. If the SEC give you a table of data, you really should use it. So which is the biggest planet? So that's going to be looking at diameter. Which planet has the largest rings? So that's going to be the visual observation from your picture. Which planet comes between Earth and Jupiter? So that's again an observation, a visual, and you know your mnemonic. Which planet is nearest the sun? So again, that's visual observation. Which planet is furthest from the sun? And bear in mind, not all of the things shown here are planets. So we're looking for the last planet. So that's now your knowledge. Which planet do you think would be the coldest? Okay, it's not asking you why, it's just asking you which. So this now is again from your observations. So hopefully you'll be able to figure those out. So in our next question, which planet is almost the same size as the Earth? So that's using our data table. Which planets are larger than the Earth? So again, that's using your data table, and there may be more. Which planet moves around the sun in the shortest time? So that's using our data table. What pattern can you see between distance from the sun and time to orbit? So you just need to sequence them for yourself and have a look and see, does the sequence match? So sequence data and find the trend. We're going to ignore our asteroids question. And would the sun look bright or dim from Pluto? Again, that's you now and using your observations. So there was no graph drawing, I don't think, in this one. Is there not? No, there isn't. So I'm going to ask you to draw a graph for me of the planets and the time taken to travel the Earth. Now you're going to do it on graph paper, or you're going to line your own paper. And again, we have names, are words and date and numbers, so that has to be a bar graph. So give that a go and see how you get on. So the last questions that you're going to have to do are having a look at here. So we have our moons of Jupiter. The large moons were discovered by Galileo Galilei, and we have data about their diameter and their density. So we also have information about the different planets in terms of their diameter and their density. And we also have information about 4 materials that are found, or 4 materials that we know, and their corresponding densities. So this is the first page, is a whole data sheet of information, and you're going to use that data sheet. So we're going backwards now, we're doing a bit of revision. You have to calculate density of it and then work out what does the answer that you get indicate, what part of this table down here could that component be. So it's doing a piece of maths and it's using the data in the table and deciding, is it water, granite, basalt or iron. Then we have Use the data in the table to state whether or not it is likely that all of the Earth is made up of these rocks. So you have the density of granite, you have the density of basalt, you have the density of the Earth, and you have to make a decision. It's going to be a yes or a no, and what from the data in the Earth says yes, the Earth is made of granite and basalt, or no. So what from the density of the Earth, so what's about that number, tells you whether or not it could be granite and basalt or it couldn't. So you're comparing the numbers from this table with the Earth data. So use the data given for Jupiter and Earth to explain why Jupiter is described as a gas giant. So here you're looking at the size numbers for both, and you're looking at the density numbers for both, and see, can you use those things in such a way to explain why Jupiter is a gas giant. And now we're not going to do the last bit. What is the difference between a moon and a planet? So that's all for today. It's a relatively short lesson. You should be able to get everything done in the time. I'm on Zoom if you need me, and we're going to start something new on Thursday.